Good morning, madam. My name is E. Ravindra from CSCD. Today I am here to talk about the project that in OS. The title of the project is E-Waste Tracks OS. Python powered operating system integration for e-waste. So this is all about the e-waste and that tracks the OS. So in this we use the Python programming language, and it says the Python powered operating system integration for e-waste. Next we will see the project overview. Once we see the project overview, in this the e-waste tracks OS is a Python integrated operating system extension designing to track, manage and optimize electronic waste recycling. The project aims to monitor system hardware usage, alert users of hardware nearing obsolescence, and streamline e-waste categorization and recycling efforts. So this is the project overview. And next we have the objectives. In any project we should have the objectives. The objectives for this project are hardware monitoring, data collection, lifecycle extension, user awareness, scalability. We will see each one in detail. Hardware monitoring. Develop tools to track hardware health and predict failure. Data collection. Gather e-waste data and simulate recycling processes. Lifecycle extension. Provide recommendation for hardware repurposing. User awareness. Notify users of recycling programs and suggest optimal recycling actions. Scalability. Ensure compatibility across various hardware platforms. So these are the objectives that we have for this project. And next we have the requirements that we should use for this project. They are: first one is the Python scripting, and the second one is system integration, and the third one is data analysis, and the fourth one automation, and the fifth one user interfaces. These are the requirements that we required for this project, and we will see each one in detail. Python scripting. Develop Python scripts to monitor system resource and usage. System integration. Embedded Python extensions into the OS kernel for real-time monitoring. Data analysis. Use data license libraries like Pandas, NumPy to analyze collected e-waste data. Automation. Automate alerts and reports for hardware nearing end of life. User interface. Develop a graphical interface for a user to visualize hardware status. And next we have the technologies used for this project. The technologies that we used are programming language, operating system, data visualization tools, debugging tools. First one is program language. Python for resource monitoring and integration. Operating system, Windows based OS for kernel integration and customization. Data visualization tools, Matplotlib for generating reports and visualization. Next, debugging tools. Use hardware simulation to test integration and performance. These are the technologies that we used for this project to implement the project. Next, we have the functional components. The functional components are hardware monitoring, e-waste classification, notification services, repost generation, portability layer. The first one, hardware monitoring. Develop APIs to track CPU, memory, and storage health. And next, e-waste classification. Implement algorithms to classify obs- obsolete hardware. Next, notification services. Notify users of potential e-waste with recommendation for recycling. Report generation. Generate periodic reports of system hardware status. Next, we have the portability layer. Ensure the extension can run on multiple Windows distribution. Next, we have the project overflow. The project overflow is nothing but how the project is works. It has the project analysis, architecture design, implementation, testing, optimization. The requirements and analysis has the it defines project goals and supported platforms. Architecture design. Design modular architecture for easy integration. Next, implementation. Develop Python modules and integrate with OS. Next, testing. Validate using real and simulated hardware. Next, optimization. Optimize scripts to minimize performance overhead. Potential challenges and solutions. In this, we have the system performance, hardware compatibility, data privacy. So, the system performance. Optimize scripts to run in the background without affecting performance. Hardware compatibility. Develop modular code adaptable to different hardware. Data privacy. Ensure service, data handling and anonymization. So this is the program code of Python that we used for the e-waste recyclation, for the tracks of e-waste, and the code is written in the Python, and we have the output of this also. And let's see the conclusion of this project. The conclusion of the project is e-waste tracks OS offers a sustainable solution to the growing problem of electronic waste by integrating Python based monitoring and recycling processes directly into the operating system. By promoting awareness, life cycle extension, and efficient waste categorization, the system contributes to greener technological environment. So this is saying that by monitoring these waste of electronic devices, we can reduce them and we can increase the greenery or greener technology environment in this nature, and it helps for the future also. So this is all about the project that we have about the e-waste tracks OS Python powered operating system integration for e-waste. Next we will see the implementation of this project. Thank you madam.
Hello everyone. In this video, we'll walk through a Python program called eWaste Track operating system. Basically, this script is designed to monitor hardware usage and help track potential e-waste by identifying components that are under heavy load or nearing obsolescence. Let's let's get started by breaking down the code section by section. So first we import three essential modules. First one is psutil, a powerful library which is used to retrieve hardware stats like CPU, memory, and disk usage. And after that, we have a time uh, which introduces delays during monitoring. And after that, random. Although it is not used directly, it is likely included for potential testing or random simulations. So first we define the class. The main class is called eWasteTrackOS. When initialized, it gathers the current CPU memory and storage usage and stores them in a dictionary called hardware usage, which is here. You can see it. This is done by calling functions from the psutil library, where this .cpu percent checks CPU usage and .virtual memory present uh, tracks memory usage, and disk usage function will monitor the storage of the root directory. So let me show you the constructor in action. Uh, Next one is a display usage. It is a method that prints out the current hardware usage stats. It loops through the hardware usage dictionary and formats the output neatly. So I'll show you the output at last. Uh, this function gives a quick snapshot of how the system is performing. So after that, we have monitor hardware method. This method runs a loop 5 times, updating the CPU, memory, and storage values each time. As you can see, we have the for loop where it repeats 5 times. Additionally, after each iteration, the program checks for potential e-waste risk by calling the check for e-waste method, which is here. There is also a time dot sleep, which has number two in it. It's a function that pauses the loop for 2 seconds, simulating real-time monitoring. So after that, we have check for e-waste method, which is crucial. It loops through each hardware component and checks if the usage exceeds 85%. If any component crosses this threshold, a warning message is printed suggesting that the component may need to be recycled or replaced. Uh, After that, we have a main function. This program main function basically initializes and runs the hardware monitor. It prints a welcome message uh, and creates an instance of the EVS Track OS class. Then it calls monitor hardware to begin the monitoring process. Here's the main part of the program when it looks like when executed. Show you the output. Uh, as you can see the co output, here it is displaying with a delay 2 seconds. So this hardware usage was checked at first one, um, where when we created a main class, we initialized three values, three functions. So this is it. In conclusion, EV's Track OS is a simple yet effective way to monitor system health and track potential hardware obsolescence. This script could be expanded to log data, send notifications, or even automate system diagnostics. I hope this breakdown helps you understand how to build basic system monitoring tools in Python. Thank you for watching and thank you.